I got to fly through this beast, Hurricane Hugo, in 1989, which was a Cat 5 storm, one of two Cat 5s I flew through. I actually flew through Hurricane Gilbert as well in 1988, which was the strongest hurricane ever recorded in the Atlantic up to that time. So I'm going to tell you a little story about flying through a Category 5 storm, what that's like. I used to tell people that the most dangerous part of my day was driving to work in the morning, but that was not always true. And certainly on this day, it was not true. So for your edification, the NOAA Hurricane Hunters have 3 Hurricane Hunter aircraft right now. 2 are P-3 Orion 4-engine turboprops, which was the kind of plane I flew through, and 1 is a high-altitude jet, which we didn't have back then. So we did a 2-plane mission out of Barbados in the Lesser Antilles Islands, and we based there to watch what eventually became Hurricane Hugo come off the coast of Africa. So here on September 10th, 1989 is the coast of Africa and the disturbance that became Hurricane Hugo. Here it is a day later. And a day after that, now it's a tropical storm. Gathering organization here. And now on September 14th, it has an eye. It's Category 1 hurricane. So off to the left of this image is the island of Barbados. And it's a situation where somebody's got to be the first to intercept a storm when you're flying with the hurricane hunters. You can only access storms that are within about a 3-hour plane ride of land. And so that means you go down to the Lesser Antilles to catch storms coming off the coast of Africa as they move across the main development region of the Atlantic. And for this particular storm, here's our crew deplaning in Barbados. We were a little bit of a press sensation as we arrived in the islands because they take hurricanes very seriously in the Lesser Antilles for good reason. So here's a picture of our 2 P-3 Orion aircraft, Miss Piggy and Kermit, flying together. And if you look at the tail of these aircraft, you can see something kind of funny looking there. That is the tail Doppler radar that we carry. And there is the Doppler radar unveiled without its cone on. The only airborne Doppler radars in the world at that time. And there are only a few more since. And these aircraft didn't only go fly into hurricanes. In the winter, we would fly winter storms. Here's a shot of the project I did in Alaska in the Aleutian Islands one winter. So it was really a dream job for a meteorologist. In the summer, we'd fly hurricanes. In the winter, we'd go fly winter storms, or sometimes we do radical projects like we got to go to the shuttle test facility at Edwards Air Force Base in California and test out heat tiles on the space shuttle. We'd mount them on our wings, fly through rain showers, and see with our fancy instrumentation how they fared. So I got to work with the world's greatest scientists. I worked with T. Theodore Fujita, Dr. Tornado, back in 1987, studying severe thunderstorms and microbursts. And I worked with all the world's greatest hurricane scientists. Every mission that we flew into a hurricane, we'd carry researchers from NOAA's Hurricane Research Division. So what a dream job it was until it wasn't. And Hurricane Hugo was the flight where I decided that maybe I should be finding work behind a desk doing some quiet research somewhere. So this was actually my workspace on the NOAA P-3 aircraft. That's the flight director station. And my job on the airplane was to act as the liaison between the crew and the hurricane scientists. So the hurricane scientists would come up with a plan of what they wanted to do, the flight patterns they wanted to engage in the hurricane. And it was my responsibility to take that plan and work with the actual flight crew, the pilots and the engineers and so on, and execute it from a safe point of view. So I was responsible for safety of the mission from a meteorological point of view. So here we are getting ready to take off. This is a view from the cockpit. You can see our other aircraft in the background there getting ready to take off with us. And here's the view that we had taking off from Barbados heading out towards Hurricane Hugo. So this is what we had to work with going out to the storm to plan for this mission. This was the satellite image from the GOES satellite showing what we suspected would be a Category 3 storm with 120-mile-per-hour winds. Now, as I was alluding to earlier, somebody's got to be the first, and we were the first Hurricane Hunter aircraft to go into Hugo. And it's always a bit of a nerve-wracking thing when you're the first to go in because you don't really know what you're going to find. I mean, yeah, you've got estimates from satellites, but the real truth comes from flying into the storms. That's why we do it. You can't just get all the data you need to know what a hurricane's doing from a satellite. You actually have to go beneath the clouds, which the satellites cannot see through so well, and take data. So we planned the mission to fly into what we thought would be a Category 3 hurricane. It was a 2-plane mission. I was on the low plane. We were going to go in at low altitude to try and sample the strongest winds of the hurricane, which is the most interesting part from a research standpoint. You really want to look under the hood and see what's going on near the surface of the ocean, because that's where the real intensification process gets going. Hurricanes are heat engines that pull heat energy from the oceans, converts it to the kinetic energy of their winds, and you really want to be able to study down low what's going on. And it's a bit of a risk, obviously, because the lower you fly to the ocean, the more dangerous it is. One downdraft can take you right into the ocean if you hit an exceptionally strong storm. So it's generally customary practice that you don't fly into a Category 3 hurricane at an altitude less than 10,000 feet. It's just not very safe. Now, we had gotten away with it the previous week in a different hurricane, a Cat 3 named Gabrielle. And we really wanted to get another data set to complement that one to study the interactions of the ocean surface with the atmosphere. So we said, hey, we got another Cat 3. We're going to try it again. We got away with it last week into Gabrielle. So, hey, let's go and fly into Hugo at 1,500 feet, which is quite low for any kind of hurricane, much less a Cat 3. So here's the view we had as we approached the first outer spiral band of the hurricane. This is called a feeder band. It's a little line of cumulus clouds that are spiraling into the center of the storm. And you can see kind of on the left of this image up high, that's the main cirrus shield that covers the storm itself. So now we're a little closer to the hurricane. Now we're underneath these cirrus clouds that cover the entire storm. And you can see the cumulus at the surface are starting to thicken up a little bit. And now we're approaching the first major spiral band of Hugo. The cumulus are getting quite tall, and we're getting ready to do our first penetration of what could be some significant turbulence. So there's the first spiral band of Hurricane Hugo in front of us. We had a good depiction of it from the radar. It showed, we would probably encounter hurricane force winds of about 75 miles per hour. Our tail Doppler radar was telling us that. So we put on our heavy duty seat belts, fastened all the gear around the cabin that might potentially fly loose and cause trouble when we're in turbulence, and got ready to experience Hurricane Hugo. So here's the view I took looking out my window of the surface of the ocean at 1,500 feet in the hurricane. And that's a pretty typical scene of what you see in a hurricane. Winds are about 80 miles per hour here, causing, a lot of blowing spray and some pretty significant whitecaps at the surface. So a little bit of a bump, nothing worse than I've seen on a bad commercial air flight. So not a big deal. And we were confident that, yes, indeed, Hugo was going to be a Category 3 hurricane as advertised. Now, this is the radar display that we had to look at as we approached the storm. We approached from the southwest side on the lower left corner of this image, and you can see there's a pretty intense area of echoes, these pink colors. That was the spiral band we passed through. After we passed through that, it only lasted a half a minute or so. We broke into this moat region here, pretty much clear of echoes, and the wind speeds dropped to about 50 miles per hour here. And we again said, well, okay, only 50-mile-per-hour winds in the moat region of a hurricane. This is probably a Cat 3. But if you look at the radar presentation of the core of the hurricane here, you're seeing some pretty intense echoes here. These white colors here, we didn't notice at the time because we had some radar problems and we had scaled the radar for the previous flight a week ago. It was actually off scale. If you look at the scale of the radar here, the white colors, you don't have anything above that. So we were not seeing the full depiction of what was going on in the hurricane. And unbeknownst to us, we weren't getting the full picture either from that satellite estimate of the Category 3 strength we had of Hurricane Hugo. And that was because that year, 1989, normally you've got two what are called geostationary satellites measuring the hurricane, but one had burned out. So we only had one satellite, and they moved it over to an intermediate position over the eastern US. And now that single satellite was having a very oblique angle looking down at Hurricane Hugo from a great distance, and was not measuring the full intensity of the hurricane. So missing data was causing big troubles with our estimation of what this hurricane could do. Partially our fault from not scaling the radar correctly, and also partially from not having the kind of satellite data that normally we would have. So I took a look at this and said, yeah, okay, 1,500 feet in a Cat 3, we can do this. We did it last week. The world's top hurricane scientists were all on board the aircraft. And, I looked to them for their experience as well. And they could have aborted the mission from a safety point of view as well by, saying, well, maybe we shouldn't chance this at 1,500 feet. And the pilots also could have done the same. But none of the three of us took exception to the data we had in front of us and said, hey, maybe we shouldn't go into this storm at 1,500 feet. And as you look at it, the most intense echoes of the storm are on the southwest side, and that was directly where we were going to penetrate through. So we hit the eye wall of Hurricane Hugo at 1,500 feet. And right away, we knew we were in a bit of a stronger storm than advertised. The winds were Cat 4. They were 135 miles per hour, gusting higher. And we were starting to get some significant turbulence. Some, updrafts and downdrafts were bouncing the plane around. But when you start to penetrate the eye wall of a hurricane, you're committed at that point. Your engines don't have enough power to climb to a higher safe altitude. You're just concerned with maintaining straight and level flight and gutting it out and getting into the calm eye. And you've only got to do it for about 2 minutes. That's how long it takes to get through the eye wall of a hurricane. So we said, okay, 2 minutes. We can probably do this. It's a Cat 4, but we've done Cat 4s once before at 1,500 feet. Back in 1980, this plane did it in Hurricane Allen. So 1 minute in, 1 minute to go. Now we're getting Cat 5 winds, and we're very concerned because we're getting 0 Gs. We're weightless. Now we're getting slammed down 2 Gs. Things we didn't fasten so well around the cabin are starting to vibrate loose and bounce around a little bit. This is not safe. We should not be at 1,500 feet in a Category 5 hurricane. It is very dangerous to do that. These updrafts and downdrafts we're seeing, they're on the order of 10 miles per hour. And if you get a really powerful downdraft, say of 30, 40 miles per hour, you're in danger of splashing the Atlantic Ocean. So, we grin and bear it. The intercom that we're all connected to, listening to each other, goes very silent, and you're, not wanting to bug the pilots. They're fighting off those downdrafts. They're crabbing over the aircraft at about a 20-degree angle to correct for the 155, 160 mile per hour winds now that are blowing at the side of the aircraft. So now, just about 15 seconds from hitting the calm eye, we hit 3 Gs of acceleration. We hit an updraft of about 30 miles per hour, followed by a downdraft of 15 miles per hour. That's a lot of wind shear. I mean, if you think about, having an updraft on the tail, a downdraft on the nose, the plane is bucking around like a bronco. And then finally, it starts to lighten up outside. We're at the edge of the eye, and I'm thinking, hallelujah, we did it. We made it into the eye of a Category 5 hurricane at 1,500 feet. But right at that instant, as it started to lighten up out there, we hit the most incredible turbulence that a hurricane hunter aircraft has ever hit and survived. We hit 5.5 Gs and followed by 2.5 Gs in the negative direction. So the plane is getting slammed by the most incredible wind shear you can imagine. In 7 seconds, we hit an updraft of about 45 miles per hour, downdraft of 25, updraft of 30 miles per hour, all in the span of 7 seconds, when the winds went from Cat 5 down to Cat 1 in the horizontal. So the plane is literally skewing through the air, bucking around. The pilot lost control of the aircraft. The number 3 engine exploded into flames. We're feeling the heat through the fuselage of the aircraft. Things are flying around inside the aircraft. The 200-pound life raft broke loose, hit the ceiling, bent a bar up there, crashed down, missed people. The tool chest flew open, and there's chisels and hammers and stuff flying around inside. The ice chest in the galley broke loose, and there's sodas flying around, knives and forks. It was a miracle nobody got injured by all the flying stuff inside the cabin. And right at that moment, as the engine is in flames, we're sinking down out of control, we pop into the eye and see this. So the pilot pulled us out 800 feet above the waves in the eye of Hurricane Hugo and pulled the lever to extinguish the fire in the engine. And there we were in the eye of a Cat 5 at 800 feet, looking around us saying, holy cow, what do we do now? So the pilot saw in front of him a wall of clouds. He didn't quite know what to do. Is that the eye wall? Is that harmless scud inside the eye? So he made this really, really tight turn inside the eye to try and avoid what he thought might be the eye wall. And it turned out it was not, but we were at the edge of the eye, and he was trying to make an impossibly tight turn to stay in the eye. And we ended up putting a wing of the aircraft in the eye wall. We're getting bounced around again. But fortunately, well, with only 3 engines, one of the engines on the wing that's missing the engine is working really hard. It goes into the red zone. And we worried that we're going to burn out that engine too. So he had to partially fly with basically one wing in the eye wall to make that super tight turn. Finally, he leveled us out into the more or less center of the eye, and we were temporarily safe enough that we could orbit the eye and take stock of our damage. So here's a photo of what it was like inside the eye as we're orbiting. That's our 200-pound life raft, that big orange thing there. A computer trailing its paper from the top. You can see it gashed a hole in the ceiling of the aircraft here. And these are our 2 flight engineers looking out the window, monitoring what's going on. And what they're monitoring is not good. And I'll tell you in a second what they were doing. So there's the galley, all the, knives and forks and stuff. You didn't want to go in the loo. It was a disaster in there. So what we ended up doing while we're orbiting the eye here, trying to figure out what to do, we're cleaning up all this, throwing everything we didn't know what to do with inside the head, so it would at least stay out of the way. And we were going to have to exit this hurricane again with only 3 engines now, and it was going to be a Cat 5. So we were very concerned for our survival. And this is the site that we had to see, surrounded on all sides by an impenetrable wall of intense cumulonimbus clouds that you could actually kind of see rotating slowly around you as you looked out. It was like being in a prison of blinding white. So we decided we needed to lighten the aircraft, because if you lighten up the plane, you can potentially climb higher and exit the storm at a safer altitude where there's less turbulence. So this is what it looks like to see a fuel dump. We dumped half of our fuel into the Atlantic Ocean to lighten the aircraft. We chucked all of our probes into the ocean, all of our drop sondes and all of our sonobuoys to measure the ocean. We had the most well-sampled hurricane ever inside the eye of that storm. And here's a little radar zoom shot showing our trajectory as we were orbiting in the eye. You can see on the left, here's where we penetrated through the most intense part of the eye wall. And now all these little circles are where we were circling inside the eye of Hugo, trying to gain altitude, trying to take stock of our situation. And we called for help. So our sister aircraft was actually quite a ways away. And, they hustled over and said, we'll come in the eye with you. and scout you out for any potential damage. But it turned out there was an Air Force aircraft that was closer by that was also tasked with investigating the storm. And they came in the eye with us, and they spiraled down to our altitude. And those two pilots did the most incredible thing. Inside the 10-mile diameter shrinking eye of a Cat 5 hurricane, they did a close flyby. The Air Force aircraft trying to figure out if we had any extra damage on our aircraft to be reported on. And turned out, yes, they did see there was actually a piece of debris hanging from the number 4 engine, the same wing as we lost our one engine that burned out on. And it was actually a de-icing boot, a piece of rubber that goes onto the engine to protect it from icing. And it had partially torn loose. And if it tore loose completely and got caught in propellers, it had the potential to destroy that engine. So they told us about that item, and they said, we don't see any other damage on you. And our pilot asked, okay, can you do us a really big favor and punch in and out of the eye wall of Hurricane Hugo to find a soft spot for us? And they said, sure. And they proceeded to do just that as we tried to climb higher. Now, there's 3 problems with trying to climb higher in the eye of a hurricane. 1, we were banked over at a sharp angle. That makes it tough to climb. 2, it's a low pressure system, so you're down 10%, so you've got less lift because there's less air. And 3, we're missing an engine, so we've got less thrust. So that plane, which normally gets up to 25,000 feet, could only get to 6,000 feet. So the Air Force aircraft very bravely punched in and out of the eye wall of Hurricane Hugo multiple times at 6,000 feet for us. And we were listening to their communications while they did it. And they, would tell us, whoa, 0 Gs, whoa, 3 Gs, don't go that way. And then, they try again, and oh, that was rough too. And finally, their 3rd penetration out, we were starting to get low on fuel because we dumped so much in the ocean. And we said, I sure hope you found us a soft spot. And they said, yes. If you look at the north eye wall here, there's a thin spot. Follow us out through that. It wasn't too rough. Yeah, the winds were gusting 200 miles per hour, still Cat 5 winds, but the turbulence was not bad. And sure enough, we followed them right out that weak part of the northern eye wall. Turbulence wasn't too bad. And we ferried back towards Barbados. Here's the view of the sun that I saw, praising the sun god vigorously as we headed back to Barbados. And there's the shot of our feathered number 3 engine as we ferried back to Barbados. And you can see our sister plane up there escorting us home. And here's the shot of Barbados as we came into land, where they had all the, emergency trucks out there and ambulances, and just in case there was a problem. And we did have some trouble landing. I don't think the pilot was used to having only 3 engines on landing, and he caused a bit of a cloud of smoke as we landed because, having to do reverse thrust and hit the brakes. But everything was fine. The landing was a success, and that was my final flight with the Hurricane Hunters. So here's a cross-section view of the flights during the eye wall penetration. The thick black line is the horizontal winds, which got up to Cat 5 here. These things labeled 1, 2, and 3 are the updrafts and downdrafts that we hit in the eye wall of the hurricane. And what happened there? Well, it turned out we hit a tornado-scale vortex embedded within the eye wall of the hurricane, something that had been suspected but never observed. And we had the bad/good fortune scientifically of actually observing one of these mesovortices, as they're called. And we do know now that they are quite common in intense hurricanes, and they can cause significant damage. They're responsible for a lot of intense damage you'll see in a major hurricane. So Hugo went on to clobber the Lesser Antilles, particularly the island of Montserrat, where it killed 10 people and did damage equivalent to 500% of their GDP. After Montserrat, it hit the Virgin Islands and winged Puerto Rico. Here's the view of El Yunque rainforest on Puerto Rico. And here is a press clipping of what happened in the island of St. Croix in the U.S. Virgin Islands, where they had to bring in federal troops. The hurricane was not done then. It went on and eventually hit South Carolina as a Category 4 storm. And this is actually the maximum storm surge that was observed just north of Charleston 20-foot storm surge caused a tremendous amount of damage in North Carolina, including the severing of the bridge here to the mainland of one of the barrier islands. And Hurricane Hugo maintained its strength as a hurricane 140 miles inland all the way to North Carolina. And it cost $23 billion, which was the costliest hurricane on record at the time. So, intellectual exercise, guess where Hugo now ranks on the list of costliest hurricanes on record? This was 1989, about 35 years ago. How many more expensive hurricanes have there been? Well, I'll show you. It ranks number 19 now. And just in the last 8 years, we've had 10 more hurricanes. 10 of the top 19 most damaging hurricanes on record have occurred in the last 10 years. So we have gotten an unprecedented pummeling from major hurricanes in the US since 2017. Oh, and I need to go to this one. This shows the NOAA's billion-dollar disaster list since 1980, showing there's been a sharp increase in expensive hurricanes, billion-dollar hurricanes over the last 30, 40, 45 years now. And unfortunately, that database has now been discontinued, so it's going to be a lot harder to figure out what's going on. So what is going on? We're pretty sure that most of the reason that we're seeing increased hurricane damage is because there's more people with more stuff in harm's way. So there's simply a lot more development that's gone on. We're building in risky places foolishly. But we're also seeing climate change start to take an increasing effect. Now, it's a fact that when you put more heat energy in the oceans, you're going to see at the higher end stronger winds. And it doesn't take much of an increase in wind speed to cause a lot more damage. A Cat 4 does about 5 times the damage of a Cat 3. It's an exponential function. So if you increase the winds by just 5 or 10%, which we expect to happen with climate change increasing ocean temperatures, you're going to see a substantial increase in damage from hurricanes. In addition, you're going to see more storm surge damage because sea level rise is occurring because of climate change. And you're going to see heavier rains because a hotter ocean will evaporate more water vapor into the atmosphere, which will then fall as rain. So here's a plot since 1900 of category 4 and 5 storms that have hit the mainland US. You can see over the last 8 years, we've taken an unprecedented pummeling. Is that the harbinger of the future? We'll see. It would be really nice to know a lot more what's going on. And certainly the cuts to NOAA and the discontinuation of their billion-dollar weather database is not a helpful thing at all at a time when we need the most information we have about hurricanes.